Case number 19. We are going to verify if this is an identity. The result when multiplying two binomial expressions, 1 minus sine beta and 1 plus sine beta, is equal to the cosine squared beta. For this case, we are going to consider the Pythagorean identities. Now, aside from the identities we did or we used in the previous cases, where 4 out of the 6 trigonometric identities can be expressed as either with cosine, sine, or a combination of both, we could also look into the relationship of these Pythagorean identities, because there are some cases where you could see the relationship even without using the cosine, sine, or the combination of both identities. The first trigonometric or Pythagorean identity is given as this one here. You have the square of sine of whatever angle, let's say beta in this case, plus the square of cosine of the same angle beta is equal to 1. If you would like to know how was this came to being, this is actually related to your unit circle, where your sine is represented by your y coordinate, your cosine is your x coordinate, hence y squared plus x squared is equal to 1. Aside from this, there are also derivations of this given Pythagorean identity. Let's say, for example, we are going to divide all these terms by sine. Okay? If we are going to divide all these terms by sine squared beta, okay, meaning we're going to divide. The second Pythagorean identity is sine squared beta divided by sine squared beta is 1, plus cosine squared beta plus sine squared beta is actually cosine over sine, that's cotangent squared beta, equal to 1 over sine squared beta, that's cosecant squared beta. This is another form of a Pythagorean identity where from this given, we divided all terms by sine squared beta. The last one is if we're also going to divide all terms by cosine squared beta. Using this, sine squared beta divided by that is tangent squared beta. Okay? Plus, you will have here cosine squared beta divided by cosine squared beta is 1, equal to 1 over cosine squared beta is secant squared beta. Now take note that for our left hand side, we have addition. So this is commutative. Either we start with cosine squared before sine squared. Here as well, cotangent squared plus 1. You also have 1 plus tangent squared beta. Now, we are not sure if all of these three identities will be used in this case rather, but let us start with our given case here. So we have the product of 1 minus sine squared beta, and then 1 plus sine squared beta equal to cosine squared beta, and we're going to show if this is an identity. Take note that the binomial expressions here are having the same first term, 1, same second term, sine squared beta, and they only differ with the operation. The first operation is subtraction, the second is addition. This could result into a difference of two squares. Difference of two squares is a result when multiplying binomial expressions of the same first term, same second term, but of different sign. And we're doing that, we simply need to square the first term. So 1 square is 1. Then you will have here a negative times positive is negative, and you square the second term, sine squared beta. This is the result when multiplying the two binomial expressions. If you would like to, you could also proceed with this portion here. FOIL method, 1 times 1 is 1. Outer, 1 times positive sine beta is, sorry, this is actually squared. So you have 1 plus sine beta. Okay. Inner, negative sine beta times 1 is minus sine beta. And we have here negative sine beta times positive sine beta is negative sine squared beta. But you could see that these two are opposites, so you could cancel them out, leaving a result of 1 minus sine squared beta. Hence, this form here. Okay? This is just the FOIL method, but this is direct result by the difference of two squares. Take note, this is the left hand side is still cosine squared, sorry, that's cosine squared beta. We are going to show further if these two are having the same quantity. Now take note, you have here sine squared and cosine squared. Out of these three Pythagorean identities, you can use this last here. Okay, I mean just first. You can subtract both sides by sine. This one here. So once you subtract both sides by sine, okay, so let me just copy it here. You have sine squared beta plus cosine squared beta is equal to 1. Subtracting sine squared beta, you can remove that. You also do that on the other side to retain equality. You would see that cosine squared beta is just equal to your right hand side 1 minus sine squared beta. This is another identity of cosine squared beta, which is actually this form here. Then we can write now 1 minus sine squared beta is cosine squared beta is equal to cosine squared beta here as well. We now have shown that both sides of the equation are just the same. In short, the given identity or the given case is an identity. We used here again Pythagorean identities and the concept of manipulating any of them. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.